Okay, now we're going to talk about the problems like you'll see in section 7.2, where you're asked to translate from like an English phrased problem and then solve it. So as you see in the example there, a 30-foot board cut into two pieces such that the longer has a length equal to 3 feet less than twice the length of the shorter piece. Find the length of each piece. In these situations, you want to choose a letter. You can choose your favorite letter or use X or Y as you commonly see. And so for this that we're looking at on the page, it says let X be the length of the shorter piece. So we want to write from the description some expressions that relate the longer and shorter piece, assuming that the X variable we chose represent the length of the shorter piece. And in that description, we see that the longer is 3 feet less than twice the shorter. So twice the shorter, we can write that as 2x, and 3 feet less, we can write as minus 3. They must then add to 30 feet total based on what we saw there at the beginning. And so all together to write this as an equation, notice we have the length of the shorter piece expressed here, the length of the longer piece expressed there, and those added together equal 30. We would then want to drop those parentheses since it just has a understood 1 in front of it. The distribution is just as simple as dropping the parentheses. 1 times 2x and 1 times minus 3. So then what we would be looking at after that simplification is just x plus 2x minus 3 equals 30, and can combine these two terms. And that's how we get to this place in the list of the example. X plus 2x is 3x minus 3 equals 30. So where would we want to go from there? Let's think about what we could potentially do. We're at the stage where we want to add or subtract something to each side. And since we've already combined terms on the left-hand side, and so we would say, okay, 30 is a number term. I need to get that 3 that's also a number term. With the 30, I can do so by adding the opposite there, adding 3 to that negative 3, and then do that same action on the right-hand side. So that leaves me with 3x on the left equals 33 on the right. And notice over here in the list view, that's where we are. We're at the point where we can divide on both sides that 3, which is multiplied by the x, to undo that operation. And that will eliminate the number in front of the x, leaving it by itself. And then take 33 divided by 3 on the right, and we get 11. So that's the length of the shorter piece. Remember, that's how we defined x. And then to determine the length of the longer piece, we would go back to our expression for it, plug in 11, 2 times 11 for 22, and then 22 minus 3, that piece is 19 feet, the longer one. So that's a rundown of that first example. Now let's look at the practice problems below and practice a few more. Let's take that first one, which says 7 less than 3 times the number is equal to 11. Find the number. And so let's just call it y for this example and go back and reread. See where we might start writing this equation. 7 less, so we know we're going to subtract 7 somewhere. 3 times the number, that's a good place to start writing out 3 times the number and just use the letter that you choose to represent the number. And we had a minus 7 we just talked about, so we can add that. And then when you see the word is, that's usually a good indicator of where to place an equal sign. we have 11 expressed after that is equal to 11. So there's our equation, and let's now solve it. We have 3y minus 7 equal 11. So the left-hand side, notice, has a variable term and number term. So we would want to eliminate the number term next to the variable term. That minus 7 we want to get rid of and move to where the 11 is. So let's start that by adding its opposite here, plus 7 on both sides. And then we're left with just 3y on the left equals 11 plus 7 on the right for 18. I'm going to come over here and write that a little bit larger so you can see it better. And now we're at the multiplication and division stage with a multiplied 3 on our number y. We say, okay, the opposite operation there is going to be dividing 3. Doing that on both sides leaves us with y on the left and 18 divided by 3 on the right, y equals 6. So our number here is 6. Notice the problem description itself doesn't say anything about y, and so we don't need to necessarily include what we chose to represent the number when reporting our final result. We're just looking to report the number, so it's 6 for this example. For the next one, notice it says find two consecutive even numbers. So you have to think about how to sequence when you see the word consecutive, either numbers or integers. In this case, even is a characteristic we need to build in. Let's first just say what is that going to be called? And let's use X for this one. If we have consecutive even integers, one of them will be X. Let's just kind of make note that the first of our two consecutive evens will be X, and then the second, imagine that's like 2 or 4, and the next even number up is 2 units above. So wherever we are at X, the next one, the consecutive one from there is X plus 2. All right, so what do we have going on with those two numbers? 3 times the first is 18 more than the second. So 3 times the first, let's write that down first. 3 times the first, that'd be 3. First one is X. And notice we have is, so that's a good place for equal. 18 more than the second. 18 more, that's addition of 18 to the second, which is X plus 2. So that second number in the sequence of evens is X plus 2, and then we're taking 18 more than that. So altogether, that makes our equation. And let's simplify it since we see some number terms collecting over here on the right. We can combine those. So rewriting here, just bringing over our X terms, combining 2 plus 18 for 20. Then we've got X terms on both sides, so we need to move them so they're together. We can do so by subtracting X on both sides. That will eliminate it from the right where we have that other number term 20, and 3 minus 1 on the left-hand side for 2x. Now we're at that stage where we can move to multiplication or division of something. We have a 2 times x. So the opposite operation there would be divide 2. We'll do that on each side. And so that x is by itself on the left, and 20 divided by 2 for 10 on the right. Now let's trace back to what that means. Remember, our first here was x. What is our second number? in the sequence of evens, well, 10 is the first, and then the second is 10 plus 2 for 12. And that looks good because we can recognize both of those are even integers. 12 is the next one up, looking consecutively from 10. So that checks out intuitively to have those two numbers as our final answer. Looking back at the description, notice it says find two consecutive even integers. So we've done that. We found them to be 10 and 12. Now, lastly, we have a nice context to look at, a little easier to approach sometimes, these that have a little more context instead of just talking about numbers and using the math terms like less than and so forth for operations. This last one is a nice example of, a rental agreement. So let's take a look at it. We have a certain tool rented for $15 plus 650 for every 15 minutes. If the total cost of renting it is 47.50, then for how long was it rented? And so that how long was it rented is the unknown in this case. Let's just say we're going to use the variable y to represent that. And let's write down some of the information from the description. It's rented for $15 plus 650 for every 15 minutes. So 650 for every 15 minutes. And our variable that's holding the place of time is going to be y. So let's place y next to that 650. And what was the total? It is 47.50. Now, I'm just going to put a star here by this because we're going to kind of have to come back and think about that because y here, based on the way we're writing it, is representing how many 15 minutes were there. So we'll have to keep that in mind when we come back in the end and think about our answer. But we have a good setup to go ahead and solve. And notice 15 and 47.50 are number terms, so it's a good idea to start by combining them. Should write that 15 a little bit more aligned with the digits it would correspond to there. And doing that operation on the right gives us 32.50. You can do that in your calculator. You don't have to do that long form or by table format. But did just want to align that for you in case you wanted to look at it that way. And then we're bringing down our 650y. 650 times y can be countered with the operation of division to get y by itself. So divide 650 on both sides. And that leaves us y by itself. Take your calculator out and divide 32.50 by 650. Let's see what you get. Confirm that you get 5. Now remember what I said earlier. With this way we have written it, we have found that there were 5 intervals of 15 minutes. 5 times $6.50. That's every 15 minutes we're paying that amount. So that 5 in conjunction with 15 minutes is needed to figure out the total of how long. So I got one last step here to say that we had 5 intervals of 15 minutes. So 5 times 15 minutes. Take your calculator and confirm for yourself that you get 75. And so now we're in terms of minutes. Recognize that when we determined 5, that wasn't 5 minutes or 5 hours. That was 5 times 15 minutes. five intervals of 15 minutes, five times of having 15-minute passed while using this rental. So all together, by combining that idea with our answer for the variable 5 times 15 minutes gives us 75 minutes total. So practice some of those problems in 7.2 as well as 7.1 for Tuesday and Wednesday of this week. And we will be back with 7.4 and 7.5. We'll skip 7.3 if you're wondering about why those sections are not available. They're not as essential from this chapter. So we'll pick up with 7.4 and 7.5 on Thursday. In the meantime, spend some time in 7.1, especially. I want you to focus there, 7.1, and also just go ahead and practice a little bit of these type problems from 7.2 as well. Have a good day.